wonderful lunch and some meaningful networking conversation. So let's continue with our afternoon sessions. So our next keynote is Embracing GitOps, Streamlining DevOps through Declarative Infrastructure Management. Please welcome Mr. Abhishek Kundalia, Director of Engineering from Pocket FM. Abhishek, he is the Head of Global Infrastructure at Pocket Entertainment, where he leads cloud infrastructure, site reliability, streaming technology, and the core content management and production platforms, powering millions of users globally with over 20 years of experience building and operating large-scale internet systems. He specializes in distributed systems, reliability, engineering, real-time streaming, and AI infrastructure. Can we have a huge round of applause for Abhishek?
Thank you so much. Just facing few technical issues. I hope you guys had a good lunch. The setting up slides for glitch. It got delayed, but I hope you guys had a good lunch. We'll start with embracing GitOps. I'll be talking about streamlining like DevOps with declarative infrastructure management. So before I start, I would like to walk you through a story. So think about a situation where I think all of you would have had a version of it in your infrastructure. It's something that we call as Ghost. Bear with me next 60 minutes for the same. So what is Ghost? Now, we talk about a situation where in your team, I'll take an example of my team. So there's an engineer whose name is Avi. He leads the platform and SRE. And they run about almost 200 plus microservices on Kubernetes. And there are 15 different teams who are deploying on it every now and then. And on paper, everything seems fine. Folks are using CI/CD pipeline, running through Terraforms, Helm charts, etc. Now, what you see in practice, generally what happens is on one night at 2 a.m., there's an production outage. One of the service called as payment checkout service goes through OM kill, as in error that one of the on-call engineers sees. Now, what happens next? In order to fix the issue, because there is a production outage which is going on, engineer goes, looks into debugs and figures out there was a memory issue. Now, the existing pods which were running at a memory of almost 2 GB, but then for whatever reasons, maybe there was a spike, etc., pods have started to kill. And in order to fix it, engineer goes, runs kubectl command, make an edit to the deployment and makes it 4 GB in order to fix the memory issue. Now that's done. It's 2 a.m., 3 a.m. and engineer just fixes it, everything works fine, goes to sleep. And thinks of, he would put those configuration into the Helm chart, Terraform, etc. So that whatever were the configuration on production would be the same configuration on the respective repositories or the code base. Now, in the morning, what happens? Because there are another sets of P1 issues, which I think all of you would have seen in your teams going through. So, couple of furthermore P1 issues that comes up, and engineer just forgets to make any changes to the real code base, and there seems to start a drift. Now, over a couple of years, what has happened? This goes on. Now, the next year, another engineer from security team wanted to make or add a new role into the cluster because they wanted it in short span of time, because there are deliveries that need to meet timeline, etc. They go and make changes onto the cluster directly. Similarly, one of the engineer, because there was another downtime and wanted to turn off a feature, used config map and made an edit to the config map on the cluster. So these are the sequence of events that has happened. Now, on one fine night, maybe let's say on a year 3, there's a big sale which is planned up. And just before the big sale, as part of like continuous normal upgrades that any teams would be doing as part of quarterly cover-ups, is releasing an health upgrade. The platform team plan to release an health upgrade, and what ends up happening is all of your configurations, the deltas that were done on the production clusters, they are no more available on the cluster. However, whatever was available on your Helm chart or the new upgraded Helm chart, which is also referred from the existing Helm chart version, gets deployed. Now, because there was not much of a traffic at that point in time, services end up working fine with 2 gigs. But after a week, there is a flash sale which is planned, and there's 8x the traffic which is expected. Now, if you will see, on the day of sale, as and when the traffic increases, though, the system starts to break. And because there was a Helm upgrade which was done recently, teams thinks that because of that upgrade, it has started to fail. However, now in order to fix it, teams tries to roll back it, and still things are not working. The reason is the previous version and the newer version both had same memory, which was 2 gigs. But nobody was aware of 4 gigs, which was changed at one point in time and which was working for last 3 years. And between these 3 years, what has happened is the context which was available with the engineer who was working had left the organization. Now, with this, right, the only fix at that point in time can be people just try to redo the bug fix that was done maybe 3 years prior, figure out it is go and kill, and they try to vertically scale the machines. And again, the way it is done is in order to, because it's a production issue, you would bypass some of these checks and you would just directly do kubectl edit command and make changes to your deployment. So if we talk about this whole story, right, there are a couple of problems that we went through. What are those? One is configuration drift, right? During kubectl edit, during a P1, somebody maybe changed HPA for scaling, somebody made changes to the memory, right? Over time, somebody made change to a config map. Right? Second is tribal knowledge. With over time, if you will see, the engineer who had the knowledge of what the changes that were being made had left the organization. Now, within this journey, also whenever a new engineer joined, would have at one point in time, would have asked, okay, these are the drifts that I see in configuration which are available on your Git versus whatever is available on the cluster. But then it's a normal saying, right? If anything works, don't change it or don't touch it. And same happened with the new engineer who joined, and everybody asked, are you confident that nothing will break? And since he was new, he did not also make any change. And that's where there was a tribal knowledge which was there with the existing engineer who left, and the knowledge is like not transferred through, right? Third, also from the perspective of audit and security, and also, right, in order to manage better, you are also losing on the audit trail. There was no audit trail of who did what, when, and why. Now, this is one of the case, right? One example that I shared a story, but I think all of you would have your own versions of such stories, and that's where your clusters become ghosts. So, there's a research that was done by Commodore in 2025, and Avi isn't alone. There's 79% of Kubernetes incidents that occur because of config drifts and changes which are not related to hardware or specific bugs. Temporary fixes are applied during incidents which are not committed back. Right? We discussed about it. Manual changes which are being done, and over next deploy, those do not follow through. Now, a lot of you might have a question that while Helm updates were happening, they have been a deployment that were being done over months and over days. Why didn't Helm update those? So generally during deployment, these Helm upgrades were only using the image tag to be updated, so not the full specs were being reconciled. Now, what's the solution to it? What if our infrastructure worked like code reviews? Right? While years back we had automated the process of deployment, however, what if we also bring in the same rule set or discipline into infrastructure deployment as well? Right. So everything that changes and everything that represents your life infrastructure should also be present in your code, which means any changes which are going through across the infrastructure are being reviewed, are being reviewed by peers, and also you can set up different audit policies, etc., etc. Now, by definition, like what GitOps says, it's managing infrastructure and application by declaring the desired state in Git. What does it mean? For example, like if I want 4 pods to run, I can define those in my Git, and some system would take care of it, and it would reflect on your production systems, right? And let's say if I want to make any changes across my infrastructure, I don't have to go into the system and check what is my current state, but your Git or basically your Git code is defining what the current state of your system is. I also mentioned about letting the automation of some system continuously reconcile to match the same. Now, what are the core 4 pillars of GitOps? One is declarative, which we talked about. Anything and everything which is there on your production system is being declared either through code or in some shape and form somewhere, and you just declare basically what is your desired state, and some systems take care of it to ensure that whatever you have declared is available on the systems. Second part or second core pillar of GitOps is anything and every change is versioned and it's immutable, which means across, like when we're talking, going back to the story of Avi, right? When there were changes which were made in the systems, we did not know who made what changes and when did they make those changes and why did they do it. But GitOps talks about ensuring that each and every change that happens is versioned and also is not changed. You cannot change a specific version set which was already done in the past. So everything remains intact. Third is there's a pull-based strategy. So there's some system which pulls automatically the changes which you have declared. And the fourth one is it's continuously reconciled. Think of a system which pulls whenever you make a change, but then over time, because somebody made some edit onto the system, and if it is not continuously reconciling, it still fails your system. Moving on next, if I just walk you through the actual journey, how does it happen, right? The step-by-step workflow of how GitOps is being implemented in real-world scenario, or how would you implement in your organization? It would be a developer would open a PR, and this PR is not specific to the application code per se, but then specific to your infrastructure code, which defines what would be your view and how would your infrastructure look like. In this case, we are talking about Kubernetes cluster state. Git repo, and basically he opens a PR, is basically he's committing those code changes or state into Git and checking it in, and it defines whatever desired state is. The next step is GitOps agent. Now, this GitOps agent could be Argo CD, Flux, etc., which runs within your infrastructure. It is not. It is part of your infrastructure, which is trying to pull what is the desired state. So it runs within your infrastructure. It pulls, whatever the latest changes are, and then the third or basically the final step would be, reconciling with the live infrastructure, which is, for example, whatever were the changes which are introduced. Let's say HPA min and max should be X and Y. The GitOps agent would be reconciling with the live infrastructure. Now, if we compare, right, what has changed fundamentally? If we talk about the previous journey of CI/CD, there's always been, a push-based system wherein there's either a Jenkins job or certain different shape and form of jobs or scripts that you would have written, and you would push those changes. Okay, let's say XYZ is my desired state, and I would run those commands and make those changes onto the infrastructure. So there's some external system which is controlling the infrastructure from outside. Now there are certain challenges with it, or I would say what the gaps that the system has. One is basically you would have production systems credentials which will be baked in, and your long-lived tokens etc. are injected in. So there is a huge security risk. Cluster is black box from outside. Failed jobs can leave your infra into a half-baked state. Now GitOps has moved to a pull-based mechanism wherein the reconciler is within the infrastructure itself, or basically the cluster itself, so you don't have to set up a different credential altogether, and your system infrastructure in itself is pulling those states, right? Now moving on, like how do you, so this ghost exists in all of your systems. Now how would you exercise your ghost? So we talked about the same situation, how it would change after a year for Avi. He has implemented CI/CD, the GitOps that we talked about. Everything is automated and all the states are available in Git. So 8x traffic has come back again, but now because there was an incident, they know what has exactly changed, and just one click away you do a GitHub or basically Git PR rollback, and the states are reset. And everybody knows what changed, etc. And in case, like for example in this case OMKill, and you want to increase your memory, you just make that git commit, and it's also being reconciled. What research shows, these are some of the DORA metrics. Generally, like deployment frequency, you would say why is this related, but then speed of an organization is also defined through how fast your process of making changes to the infrastructure is. While we have automated a lot of application code deployments, etc., however, we also one of the ways to optimize or move to a high frequency deployment organization is how do you ensure that infrastructure changes are done really fast, and you can roll back really fast during incidents. Talking about the tooling landscape for GitOps as a strategy to be implemented. For app delivery, you can use like Argo CD, Flux CD, etc. For infra provisioning, Terraform, a lot of you would already be using it. And then for infra provisioning, Crossplane. 4 pitfalls like nobody warns you about when you are implementing GitOps. One is secret sprawl. So what does it mean? Whenever you're trying to implement a lot of this early on, you would take a call around, okay, maybe let me commit those secrets in my infra repository, because anyways infrastructure needs to have access to all of those. But do ensure that you take those right calls early on and you use secret managers, etc. Similarly, repo sprawl, there's always a confusion about mono versus multi-repo. Make those choices in accordance with how does your organization overall infrastructure looks like in long run, because eventually it becomes very difficult. Then it's drift noise and then reviewer fatigue. After a point in time, you would have a lot of changes coming in, which your engineers would have to review. And in order to solve that, the best way would be ensure that policies, etc. and guardrails are in place, so that your engineers don't have to review each and every infrastructure changes, and there is a first level of checks in terms of the policy as a guardrail is already done. This is the GitOps adoption ladder. You go through 4 phases, which is audit, wherein you figure out what are the infrastructure changes which happens over time. There's a pilot, which usually you would do with probably one repository, etc., or low impacting service, and then expand. Once it works for one repository, you move it to all of your repositories, etc. And once you feel that's stable, then you move into enforcement, where you block anybody to make any external changes to your infrastructure. Now, so this would be your, Monday morning playbook. Select one service, install it in audit mode. Don't make it to basically write on your infrastructure, but it would just monitor and call out those drifts, and then write policies accordingly. So somewhere in your stack, there's a ghost, right? And you know how to solve it now. Also, I would just close it with one point. With AI coming in, the foundations that can be set specific to AI would be around, because you have complete infrastructure in Git, AI agents can read through and know those states, and it would become very easy for agents eventually to even play around. So that's it from my end. Thank you so much. Open for questions. You can reach out to me over here. Thank you so much.
With this, we move on to the next. So our final keynote of the day is DevOps.